Hi and welcome. In this video, we will be seeing pre-order, in-order and post-order traversals of binary tree. Fine. So we will see how to create a binary tree, that the recursive solution for the pre-order, in-order and post-order traversals. Fine. So first of all, before coding, I will explain you the recursive approach of these three, that is pre-order, in-order and post-order, and write your own code. Okay, fine. Then when you resume the video again and see the code, just match your codes. Okay, so don't copy paste the code from here, just learn first. Fine. So what I will do, I will just explain the pre-order, in-order and post-order recursive solutions with you. Okay, and then just simply write those codes. I will give you almost the entire pseudocode. Fine. You have to just implement them. After that, obviously I will implement the binary tree, how to create a binary tree. Then we will do a pre-order, in-order and post-order. Fine. So let's now begin, and let me explain you the recursive approaches of pre-order, in-order and post-order traversals. So this is the binary tree that we have: 1, 2, 3, 4, 5, 6 and 7. These are my nodes. So first what I want to do, I want to do a pre-order traversal. I want to traverse this tree in pre-order format. Okay, in pre-order format. That is pre-order traversal. Now what pre-order traversal says is, first you have to print the root. Okay, then go to the left side and then go to the right side. Now this is exactly the recursion solution. Okay, first print the root, go to the left side. After that, after left side is over, go to the right side. Fine. So how it works is, it's very simple. When you traverse the tree, you always traverse the tree top down and left to right. Okay, top to down and left to right. Fine. So first we will go here, and whatever the first node that we have, that this is the first node that we encounter, and this node is encountered for the first time. Okay, every node can be encountered 3 times whenever you are traversing. I will show you. So this node is encountered the first time. This is my root node, and in pre-order the root is printed first, so 1 will be printed. Fine. Then we will move top to down and we will encounter 2, so 2 will be printed. Then we will move again top to down and we will encounter 4, and 4 will be printed. Now what is happening, I am printing first, then I am going to the left side. I am printing 2 and I am going to the left of 2. Now when I come to 4, here I have no nodes, so this will be null, and now I have encountered the 4th second time. Okay, just remember this. This will be null. Now I have encountered 4th the 3rd time. So first was here, second was here, and third was here. So every node is encountered actually 3 times. So in pre-order, whenever the node is encountered for the first time, we will print it. Then go to the left side, but this was null, so we return back. We go to the right side, but this was also null, so we return back. Now the left and right of this node are over, so we will return back to its parent, that is 2. Now 2 is encountered for the second time. Here was the first time, and now it is the second time. Now its left is over, so root is over, the left is over. So in this case, this was the left subtree, and for this the root was 2, correct? So 2, the root is printed, not an issue. We go to the left and we printed the left side of the tree, not an issue. Now we go to the right side of the tree. Now when we go to the right side of the tree, we find 5. So now tell me what will happen. You know what will happen. Okay, I've explained the same concept. Now 5 will be encountered for the first time, so 5 will be printed. It's very simple. Now also you know what will happen. We will go to the left side, it is null, we will come back. Now 5 is here for the second time. We will go to the right, it is null, we come back. Now 5 is encountered for the third time, correct? Now we will go back to 2. Why? Because for 5, left hand side is over, the right hand side is over. So the first step was print 5, the next step was go to the left, the next step was go to the right. Now since these 3 steps are over for the node 5, it will return back to its parent. Now see, for the 2, we have encountered 2 for the third time. So first was here, second is here, and third is here. So now what will happen? You know what will happen. For 2, we printed 2. We went to this left, we went to it right. Okay, left and right. Now since all the 3 steps are over, we will go again to 1. So now 1 is encountered the second time. So this was the first time, this was the second time, and now for 1, the root printing is over. As we can see, the 1 is printed. We went to its left side, so this was the second step, that we went to its left side, and what will happen is, its left side is now completely over. Now it will go to its right side. So printing is done, left side is done. Now we will go to the right side. So when we go to the right side, we'll encounter 3 for the first time. We'll encounter 3 for the first time, and since it is encountering for the first time and pre-order is used, we will print it. Okay, now we'll go to the left side of it. So first printing the root, that is 3, then we will go to the left side of it. So when we go to the left side, 6 is encountered for the first time, so 6 printed, okay, because printing is first. Then we will go to its left and we will go to its right. You know what will happen, left is null, right is null, so because both are null, now it will return. So here it is second time, and now it will come to the third time, same as 4. Okay, now 3 will encounter for the second time and it will go to the right. Why it go to the right? Now think why it went to right. I have already explained you why it is going to right now. So for 3, the printing is over and going to the left is over. So what is left? So now only right is left. So there are 3 steps. First step was printing it. We printed it. Then we go to the left side of it. We went to the left side of it. Now we will go to the right side of it. Fine. So now we go to the 7. 7 will be encountered for the first time. It will be printed. See, 7 is encountered for the first time, so it will be printed. We will go to its left side. It will be null. It will come back the second time it is encountered. Now it will go to its right. It will be encountered for the third time when it comes back. So here it is coming back for the third time. Okay, so the 7 is encountered first here, second here, and third here. Okay, now its root is over, its left is over, its right is over, so it will simply return back to its parent. That is nothing but 3. That is nothing but 3. So now what will happen to 3? Just imagine what will happen to 3. So as same as 2. So for 3, the printing is over. So 3, the printing is over. We went to the left side of it, it is also over. We went to the right side of it, it is also over. So all the 3 steps of preorder are over for 3. So now it will simply return back to 1. Now 1 is encountered for the third time. First was here, second was here, and third was here. For 1 also, now the root is printed, not an issue. We went to his left side, so the whole left side is printed, 2, 4, and 5. We went to the right side, whole the right side is printed, 3, 6, and 7. So this is my preorder traversal for this tree, that is 1, 2, 3, 4, 5, 6, and 7. Now I have explained you that single node has 1, 2, and 3. So single node is encountered at least 3 times. It is encountered for 3 times. First is here, second is here, and third is here. So it is a very simple approach to print in order, and post order. So many of you might have guessed what will happen. So in pre-order, when the node was encountered for the first time, we were printing it. So in order, when the node will be encountered for the second time, we will print it. And for the third order, when the node will be encountered for the third time, then we will print it. So what is in order? In order is first we will go to left, then we will print the root, and then we will go to right. Fine. And what is post order? We will go to the left, we will go to the right, and we will print at the last. Okay, since here printing is first, so whenever a node is encountered, it is printed first. Okay, since here the printing is second, so when the node is encountered for the second time, we are printing it. Here the printing is last, so when the node is encountered for the last time, that is the third time, we will be printing it. Okay, so this is a quick approach. If someone gives you any type of tree, and asks you for pre-order, in-order, and post-order traversal, so don't use any method or stack. Simply what you have to do, you have to just see the order. So whenever a node is accessed for the first time, just print it in pre-order. If it is accessed the second time, then in order, and then the last, that is post-order. So let me explain you for in order also, and then we will see the recursion approach for this. Okay. Now for the same tree, let's see the in order traversal. Okay, for the same tree. Now what I have told you is, whenever a node is encountered for the second time, at that time we will print the node. So the first step is, we will begin from here. So the first step is go to its left. So we will go to the left. So 1 is encountered for the first time. Okay. Now 2 is encountered for the first time. Now what is the first step is, after I am here, so these are all my recursion calls. Just think of these are my recursion calls. So when I am here, I am following the first step, that is go to the left. Now when I am here for the second node, so for this we have to follow all the 3 steps again. Okay. So first go to the left. Okay. So the 4 is encountered. Now for this again we have to follow all the steps. So go to its left, there is nothing, come back. Now here it is encountered for the second time. The 4 is encountered for the second time. Since the 4 is encountered for the second time, in order, we will print it. Okay, so we will print 4. So this is the second step that 4 has completed now. Now go to its right. Now when I go to its right, there is nothing, I will come back. Okay, so for the node 4, all the 3 steps are over. Since all the 3 steps are over, it will return to its parent. Now when it returns to its parent, 2 is encountered for the second time. And we know in order, when a node is encountered for the second time, we will simply print it. Okay, So the first step of 2 is over, that is going to its left and printing all the nodes in the left, that is over. Now it prints itself. Now it prints. In the second step it prints. Fine. Now the third step is go to its right. Go to its right. So the 5 is encountered for the first time. So will it get printed? I have just explained that in order, the second time when a node is encountered, it gets printed. Okay, not for the first time. So what happens in the first time is the first step is go to the left. So we'll go to the left. There is nothing. We will come back. Okay. Since we are coming back, now 5 is encountered for the second time. Now will it get printed? Yes, now it will get printed, because in order, when a node is encountered for the second time, it will get printed. Now the left side is over for node 5. Printing is over for the node 5. So now what is the third step and the last step is go to its right. Now we are going to its right. It is nothing. It will come back. Okay. And all the 3 steps of node 5 are over. We went to its left, we printed it, and we went to its right. Now it will simply return to its parent. Okay. So now here the node is encountered for the third time. Okay. Nothing will happen. Now for this node 2, the left side is over, that we printed all the nodes to its left side. Printing of itself is also over. See, 4 and 2 it's printed. This was the left, this is itself, and now we went to the right side and printed all the nodes in the right side also, that is printing 5. Correct. Now since all the 3 steps are over, it will go to its parent, that is 1. Now 1 is encountered for the second time. It was encountered for the first time here. Now it is encountered for the second time. Now it will get printed in order. I have explained you this. Okay. Now what will happen is, for 1, the left side is over completely, that is 4, 2 and 5, and it has printed itself also. So the second step is also over for the node 1 here. Now only the third step is remaining, that is going to its right. Now when it goes to its right, 3 is encountered for the first time. Now for the node 3, first step is go to its left, so it will go to the left. Now node 6, the first step is go to its left, so it will go to the left, but it is nothing there, so it will come back. Now here it is encountered for the second time. First one was here, second one was here, so it will now print it. Now for node 6, left side is over, printing is over, so only the third step is remaining, that is go to its right, but nothing is there in the right, so it will come back. Now all the 3 steps of node 6 are also simply over. Since it is over, now it will go to its parent. It will go to its parent. Now 3 is encountered for the second time. So the first step was 3 was, it went to its left. Yes, it did. Here it printed everything in its left. Yes, it did. Now the last step that is remaining, the second step that is remaining here is print itself. So it will print itself, and now the last step is go to its right. So now it will go to the right. Now for node 7, it is encountered for the first time. All the 3 processes will take place. So the first one is go to its left. Now you know everything. Now I think I have explained it. So now it will come back, it will get printed, it will go to its right, it will come back because nothing is here. So for node 7, the left side is over, there was nothing. It will print itself, that is printed 7, and it went to the right side, there was nothing, and come back. So for 7, all the 3 steps are over, and now we will simply go back to node 3, that is parent. Fine. So now here for the node 3, we went to its left side, we printed all the things in the left side, we printed itself also, and we printed all the things in the 7, that is on the right side. Now all the 3 steps are over, therefore it will go to 1, and here 1 will see that I have printed the left side of mine, I have printed the right side of mine, and I have printed myself also in the middle. So the in-order traversal for this tree is complete. It is complete. So now just write the postorder traversal. Pause the video and write the postorder traversal. I know it is very simple. I have explained you. For the first time when a node is encountered, we print for pre-order. For the second time when a node is encountered, we print the in-order. Now when the node is encountered for the third time, we will simply print the post order. So just pause the video, do not copy it, just pause the video and think of the post order. I am writing the answer now. Okay. So the 1 is encountered for the first time, nothing will be printed. 2 is encountered for the first time, nothing will be printed. 4 is encountered for the first time, nothing will be printed. 4 is encountered for the second time, nothing will be printed. 4 is encountered for the third time, yes, 4 will be printed because 4 is encountered for the third time. Now 2 is encountered for the second time, 1 was here, second was here, so nothing will be printed. 5, 1, 2 and 3, yes, 5 will be printed then. Now it will go back to 2. Now 1, 2 and 3, yes, 2 will be printed because it is 3. Now can you guess what will be the next one? Will it be 1 or will it be 6? Guess. Will it be 1 or will it be 6? For those who have guessed 6, you are correct. You are absolutely correct. Why? 1 will be encountered for the second time here, not the third time. 3 for the first time, 6 for the first, second and third. So 6 is for the third. So 6 will be printed. Now 3 for the second, 7 will be printed like then. Now 3, because 7 will return, and here it is the third time for 3, and then a 1. So as you can see, root is as the last. For the postorder, root is as last. First we will print the left side and the right side, root, left side, right side, root, and the left, right, and root. Fine. So these were my pre-order, in-order, and post-order. These were already explained before. I've just shown you a method for this left, print, right. Okay. So first step is going to its left, second step is print it, and the third step is going to its right. Now in the pre-order, it was first print, go to left, go to right. In the post-order, first it will be go to left, then it will be go to right, and then print. The last step is printing. Okay, for the post order. Now this same thing we will use in recursion. The exact same thing we will use in recursion. The recursion concept is only of 3 steps. The first step is for in order, go to its left. The second step is go to print it, and the third step is right. This is the only thing in recursion. Fine. So now what I will do, I will just create a binary tree. Okay, I will create a binary tree. After creating the binary tree, I will write a pre-order code for this one. Okay, I urge you to write it on your own, but I will write a pre-order code for it. Fine. Then after writing the pre-order code for this, I will explain you the recursion process. I will explain you the recursion process. After that, you have to write the code for in order and post order by yourself, pausing the video. By pausing the video, just write the code for in order and post order. Now what I'm going to do is I'm going to simply write a code for pre-order. Fine. So before going to the code, I wanted to explain you that whenever I am drawing this, then one. So what is this one? This is nothing but a node. Okay, and it has a left pointer and a right pointer. Okay, so it is nothing but a node containing a left pointer, data, and a right pointer. A left pointer, a data value, that is 1 in this case, and a right pointer. Okay, now since we have a 2 here, so what we have, left pointer is pointing to another node whose data value is 2. Okay, some address and data value 2. It also have a left pointer and a right pointer. From the left pointer, it was pointing to 4. So here also I have a node with a left pointer and a right pointer and a data value as 4. Correct? So in code, first we have to define this node having a left pointer and a right pointer. Now if you have learned C, you know for this type of operations we use structures. Correct? In Java, we will have a different class. In Java, we will have a different class for creating our nodes. For example, a class node. So for creating a tree, we will have a different class node. Okay, from our main class, we will be simply adding the elements in the node. Okay, and we will have a different class, that is a one class for creating nodes. When we have our main class, now main class will be used to access the node class to insert the elements in my tree, and main class will be also used to call the methods. Now these methods, for example, will be in this tree traversal class. Okay, so main method will be simply only be used for calling the methods of tree traversal class and for using the class node to create my tree. Okay, so there will be no methods in main. Okay, in the main class we will have no methods. This will be only used to call the methods of tree traversal class and to use the class node to create our tree. Fine. So first we will create the class node. Now in the class node, as in structures, we will have a left pointer, we will have a right pointer, and we will have a data value. It is very simple. So let's code now. So now in the code, I have a node.java. This is my class. Fine. Here what I will have an integer type data. I will have an integer type data, and I will have a node type of my left and right. My left and right. This is really simple. This we have done in structures also. If you have learned structures, this we have done it. Okay, if you haven't, so this is how we do it in Java. Okay, and int item. So this is a constructor. Whenever an object of node class is created, this constructor will be called with my parameter as item. Okay, now I will simply add item to data. I will simply add item to data, and I will make left and right for now as null. Left and right for now as null. Okay, left and right as null. 1 second, equal to null. So my node will be created. For example, I am sending my item value as 5. So my node will be created with 5, with my left null and with my right null. Now now again, when the node is created, now what I will do, I will simply call this node dot left, node dot left to create the left child, and node dot right to create the right child. To input the values in my left and right. Okay, if I want to create the left of this, what I will call node dot left, 2 times left, and I will be here. And for this one, node dot left and node dot right. Fine, and I will be here, left, right, left, left. So this is really very simple, really very simple. Now what we will do, we will go to our main class, and here I will simply write a simple code that for creating my tree. Now this tree is nothing but in tree traversal, So in this tree traversal, what we will write, we will simply create a root node. We will create a root node. Okay, node root. This is a reference variable. Now root is a reference variable for type class node. Okay, root is a reference variable for type class node. We haven't initialized it yet. Okay, there is no initialization, so object is not created, therefore this method is not called as of now. Fine. Now we will simply create a tree traversal constructor. Okay, so now you know what is the use of a constructor. Whenever I will declare my tree traversal class object, okay, this constructor will be called, and in the beginning what it will do, it will assign null to root. In the beginning what it will do, it will assign null to root. So now root is a reference variable of type node, and it will have null. It will have null whenever my tree traversal class object is created. Now you all know this. Okay, if you are watching this video of tree traversal, you know what is a class, what is a reference variable, now what is my constructor, and how constructors are used. Now I will go to main. Now I have my node class, I have my tree traversal first part, that is creating a root node and nothing else. Now I'll go to my main class and I will use these 2 points. Now tree traversal is my class. I will declare my tree as my reference variable, and now I will declare my object. Now I will create my object. So new tree traversal. So my object is now created. Whenever this is created, new tree traversal, it will go here. Okay, and it will initialize root to null. Fine, no issue. Now using my reference variable, what I can do, I can access this root. Using my reference variable here of the tree traversal class, I can access my root. So tree.root equal to, now from null I will change it to new node 1. So now what is happening, now new node is nothing but the object of type class node, of a class type node. So this is an object of a type class node. So what will happen, you know what will happen, whenever an object is created, its constructor is called. So now the constructor is called. Now when the constructor is called with item equals to 1, what it will do, it will input the item into the data field, and it will make left and right equals to null of the node. Fine. So now what it will happen, in the beginning when this object was created, it went here, it initialized root to null. Now I am using the reference variable of tree to access this root, and in this root I am initializing my value as 1. It is very simple. The item will go to the data, that is 1 is go to the data, and the left and right will become simply null. Now what I want to do, I want to add tree on the left side of it, tree.root.left. On the left side of it I want to add 2, as we have seen. So new node, I will create a new node and I will input 2 in it. So on the left side of 1, that is the root, I am adding a new node with a data item 2. Okay, so on the left side of 1, here you can see on the left side of 1 there is 2, so I am adding this. Okay, on the right side of 1, what we want to add, on the right side we want to add 3. So tree.root.right, okay, equals to, I am creating a new node, and in this node I will simply pass 3. So now what will happen, on the left side I have 2, and the right side I will have simply a 3. Fine. So now this 2 and 3 are created. Now I can add more to this 2 and 3 on their left and on their right, and on their left and on their right. This is what I'm going to do further. Now I want to add something to the left side of 2. So the left side of 2 will be accessed by this line, correct? So simply tree dot root, that is 1, dot left, that is left of 1, that is nothing but 2, and on the left side I want to add, so left again will be equal to new node, simply 4. So on the left side of 2 now I have 4. As you can see here, I have a 1, that is my root, Now root.left I have written, so in the root.left I have 2. Now in the left I want to add a 4, so I am adding a 4. Now what I want to do, tree.root.left, that is now I am at 2, and on the right of 2 I want to add 5, so it will be simply new node and 5. It's very simple. So now 4, after 4 here 5 will be added. So it was my 1, 2, 4 and tree, sorry, this is the root, this is left of the root and the right of this one. So here 5 will be added. As you can see, root, left and right. So now what I want to do, this one is complete. Now on the right side I have added 3, on the right side I have added 3. So now what I want to do, this was right, so root of right is 3, and in the left I want to add 6, and in the right I want to add 7. So now do these 2 steps. Okay, pause the video and add 6 and 7 in my tree. Okay, pause the video and do it. You can do it, it's very simple. Now what it will write, for those you are thinking that we will write root dot right dot left and we will add 6, they are very correct. Why? Root dot right is 3 and the left of this whole thing is nothing but 6. So root dot right dot left, we will have a 6. Correct? So tree dot right, sorry, the root dot right dot left. Now here I will add simply a 6. Yes, new node 6. Fine. Now what I want to do is now add 7. Now add a 7. It is very simple. We go to a tree. Okay, dot root dot right and dot right. Fine. Why? See this. We have a 1 to right is 3 and to its right is 7. So 2 times right. Fine. So tree dot root dot right equals to new node 7. So now I have my whole tree completed with me as I wanted. Okay, you can add any number of nodes like this. You can add any number of nodes like this. It is not an issue. Just try it. Now what is my tree? My tree is simply this. Okay, using only this much code, I have created my tree. Fine. So now after this, what we have to do, now we have to write the preorder, inorder and postorder traversal code for my tree. I will show you the preorder code. I will explain you the recursion function for it, but you have to write your own code for inorder and postorder. It is very simple. Okay, just write your own code. Obviously I am writing it, but don't see that part of the video. Okay, after writing your own code, then only see the part of the video. Fine. So now I am going to write the code for preorder traversal.